All right. You guys can get up. One second. Sorry, Lynn. Alright, so today we are going to be talking about angle relationships. So you're going to be able to identify relationships between angles including adjacent, linear pair, vertical angles, supplementary, and complementary angles. I've defined some of these words for you already, but you're going to have to actually use them. But first we're going to review some distance and midpoint for those of you that may have struggled. So to do the distance formula, this is the distance formula. You need to know it. Your test is next Thursday. So we have today and Tuesday are angle relationships. Wednesday is a review day, so I'll hopefully have the review packet for you guys on Tuesday so you can get started on that. I will post the answers to the Google Classroom as well when I get it, okay? And then Thursday you will have your test, all right? Your construction portfolio will not be due next week because you haven't even learned everything that's in it, so it'll be sometime the following week, okay? And I'll keep you posted on that. All right, Madison. What is the change in x? It is. From 3 to -1 is 4. Melinda, what is the change in y from 5 to -7? Be careful. 5 is on the right side of 0, and -7 is on the left side of 0. So, so you have to go 5 and then another 7 for 12. You plug it in. What's up? What'd you say? Oh, you have the answer. Okay, just one second. Did you simplify the answer? Okay. Okay, so what do you get inside of there then? So you do get 160, but don't forget that this is not the answer, guys. You still have to do your factor tree. So 16 times 10, 4 and 4, 5 and 2, 2 and 2, and 2 and 2. Yes. Okay, so I have two groups of 2, 2. So what does that make it, Cameron? And then what's underneath? Yep, 2 times 2 is 4 because you take 1 out of each. 2 times 5 is 10, so your answer is 4 square root 10. Questions on how to find your change in y and change in x? That's important. If you can't do that, it's going to be a problem. Questions on simplifying a radical? We okay there? All right, go ahead and get that copy down, and then we're going to do the midpoint. All right, midpoint. So again, something that I've been stressing with you since day one is that you need to read your directions and understand what they're saying. So one says distance, this one says midpoint. To find the midpoint, you add the x's together and divide by 2. And then you add the y's together and divide by 2. To get your ordered pair, that is the midpoint. So we'll do x's first. Dylan Keith, how do I find the x's? How do I find the midpoint of the x's? What will I do? So look up here, Dylan. What does it say you do to find the x's? So what are your x's that you're going to add? And what are you going to do from there? Good. So I'm just going to leave it as 5 over 2. Paige, what do I do to find the y's?
You add 6 and -10 and then divide by 2.
Brandon, vote. How do I write that up as an answer then?
5/2 power -2.
Perfect. All right. So that's just a little recap of some of the things you have learned so far. Today is going to be another day like points, lines, and planes day. Remember that day where we just talked a lot about definitions? Remember when I said you might want to use flashcards in this class? You're learning a lot more definitions today and Tuesday. It's just a lot. So it's a lot different from algebra. Algebra is very linear. Like it goes from one thing to the next. It makes sense. It's cohesive, right? It's like it just makes sense. Geometry has so many different areas in it that it doesn't all seem to fit as well, okay? So it makes it a little bit more difficult for some people. If you need to make flashcards and stuff to understand what the directions are asking you, you might want to do that, all right, guys? It is going to be it might be easier for some of you, but it might be more difficult than algebra was for others of you. I know for me, geometry was harder for me than algebra was. So, just so you're aware. Okay, so let's define some things here. Adjacent angles, which remember that day that you guys had the constructions in there, was the word adjacent angle, and I went over that with you for that reason because you didn't know it yet. Here's the definition here. So adjacent angles are two angles that lie in the same plane and have a common vertex and a common side, but no common interior points. So they have to share a vertex and a ray, share a vertex and side. But they cannot be inside of one cannot be inside the other. So when I think of the word adjacent, I think of next to. And just so you know, the side that they share is a ray. All right. So the first question there says, are ABD. So when I follow these angles, when they say the letters, I start at the first point and I just like trace my finger along it. So when you're writing the angles, make sure you start at one of the rays and trace your finger to be able to get like the actual like correct letters because the vertex needs to be in the middle. So are ABD and CBD adjacent angles? Lexi, are those adjacent angles?
Yeah.
Why?
Because they share the vertex.
They share a vertex of B. And what's the ray that they share?
BD.
Ray BD. And they are next to each other. I guess I decided that T goes with both of them next to each other. Okay, how about ABC and DBC? Are those two adjacent angles, Ayana? So it's the pink, ABC, and the purple, DBC. Are those two adjacent? Okay, so they share a side, right? You guys see that? They share a vertex, but one cannot be inside of the other. Is one inside of the other? Yeah, so is that adjacent? No. Angle DBC, I put BBC. DBC is inside angle ABC, not next to. Okay, we can also call angles by a number inside of the vertex, so that's what they're doing in this one. So it's asking if angle 1 and angle 6, or angle 2, sorry, where I got 6 from, are adjacent. Jordan, are those two adjacent?
Yes.
What ray do they share?
ST.
And what vertex do they share?
S.
And they are next to each other. Okay, questions on what an adjacent angle is? Questions on adjacent angles? Go ahead and write that down when you guys are ready. I'll move on. All right. A linear pair is a pair of adjacent angles, so they have to be next to each other. In which the non-common sides are opposite rays, which means they form a straight line, and a straight line is 180 degrees. So, opposite rays go in opposite directions. So in this case, the opposite rays are AB and BC are opposite rays. And notice how I put the hat on top of the AB and BC. They have one arrow. So when it's talking about the opposite rays, those are opposite rays. They're adjacent because they share the ray DB at vertex B. So what we know about a linear pair is angle ABD, so the measure of angle ABD, plus the measure of angle DBC has to be what? If they form a linear pair, what does that measure have to be? Brandon?
180.
Has to be 180 degrees. A linear pair has to be next to each other. They cannot be separate. They have to be touching each other. You have any questions so far? All right. A vertical angle are two non-adjacent, so they cannot be next to each other, formed by two intersecting lines. So vertical angles make an X. Vertical angles are a cross from each other. So like 5 and 7 are vertical angles because they are across from each other, not next to each other. And 8 and 6 are vertical angles because they're across from each other. So angle 8, because there's no, do you see how there's no letter here in the middle? So we have to use what's inside of it. So angle 8 and angle 6 are vertical angles. And vertical angles are the same. They are congruent. So the measure of angle 8 equals the measure of angle 6. So they are the same. The other set of vertical angles we have are angles 5 and 7. So angle 5 and 7. So angle 5 and angle 7 are also vertical angles. So angle 5 is equal to angle 7. Okay, so look at those and see if you have any questions for me there. Landon.
Can I go just back real quick?
Quickly, yeah.
Okay.
This is the homework. Just leave at 10 and then you have to go. Okay. When you're ready, go ahead and flip. We have 2 more definitions and then we're going to do the 2 examples. We'll finish the back page on Tuesday. You will still be able to do your homework. All right, so complementary angles we've kind of talked about before, but they add to 90 degrees. That, remember, sum means addition. And they do not have to be adjacent. So they do not have to be adjacent. Do not have to be next to each other. Do not have. So what we know is that this symbol here means 90 degrees. So angle 9 plus angle 10 is 90 degrees. So who can tell me then, if we do not know this, I'm going to call this angle x, what would the measure of angle x be if these 2 angles are complementary angles? What would the measure of angle x be if those 2 are complementary? How'd you get that?
90 minus 65.
Yeah, you know that the 2 of them together should add to be 90 if they're complementary, right? So if you subtract 65 on both sides, that gives you x equals 25 degrees. So supplementary angles are 2 angles that have a sum, so they add to 180 degrees. So this is very confusing because you learned linear pairs also add to 180 degrees, right? So listen to this very carefully. Unlike linear pairs, these do not have to be next to each other. So what I'm saying is, like, a linear pair has to be touching, like has to have that adjacent. But a supplementary angle does not have to have that, okay? So linear pairs are always supplementary. But just because something is supplementary does not mean it's a linear pair, all right? Because they don't have to be touching. So unlike a linear pair, the angles do not need to be next to each other.
Does that mean when it's a linear pair, it's also a supplementary?
but like just because it's supplementary. Like this first example is also a linear pair, but that second example is not. So Sophia had a really good point here. So that first example is a linear pair because they share that side, right? But the second example is supplementary, but it's not a linear pair because they're not touching. All right, that's what that's saying. All right, so what we know then is the measure of angle 11 plus the measure of angle 12 is 180 degrees. So Cole, if these are supplementary angles over here, and I call this angle x, what would x be?
50.
Yeah, because x plus 130 equals 180 degrees. So if you subtract 130, you get x equals 50 degrees. All right, go ahead and get that copied down, and then we will get on to the 2 examples, and then we'll get your homework out to you. Okay. So this says find the measure of 2 supplementary angles if the measure of one angle is 6 less than 5 times the measure of the other. So what do we know about supplementary angles? Landon?
They are always 180 degrees.
Add to 180 degrees. So we have 2 angles that are going to be adding to 180 degrees. So we have to figure out what those are. They could be a linear pair, but they don't have to. So I'm just going to draw 2 angles that could be the right measures. And it needs to be in terms of one of the angles. So I'm going to call one of my angles x, just so I know that I can use it. So when you do this, you're just going to call one of the angles x, and then we're going to use the information. So if the measure of the one angle is 6 less than, what does 6 less than mean? What does that mean you're going to do? You're going to subtract 6 at the end. 6 less than 5 times. What does 5 times mean? Multiply the measure of the other angle, and we call the other angle x. So that means that this angle is 5x minus 6, and our original angle we're just going to call x. So we have to add those 2 together. And then I can solve. So x is 31 degrees. So one angle is 31 degrees. What is the other? What is the other? What's the other angle? Alana, what do you think it is? What did you do? Okay, so do 5 times 31. And then subtract 6. What do you get? 149. So one of the ways you could do is plug it back in. What's the other way you could have done it? Maybe a little bit quicker. What could you have done instead? Yeah, you know they have to add to 180, so you could have just done 180 minus 31 and gotten something. All right? Next one here says find the measure of the complement if one angle is 10 more than the other. We know that complementary angles add to 290, sorry. So we're going to have 2 angles that add to 90 degrees. So I'm just going to draw one here, call one x. 10 more than means you're doing what? What does that mean you're going to do?
And
Add 10 at the end. And then it says 4 times, or does it, yeah, it says 4 times the other. So what does that mean we're going to do for the 4 times the other? 4 times x. So we have 4x plus 10. So we have 4x plus 10 plus x equals 90. So x is 16, so one angle is 16 degrees. How can we find the other one then? Brandon?
Subtract 90 by 16.
And what do you get?
74.
Or you can plug it in. All right?